Morning, everyone, and thank you very much for joining us today. It's really a pleasure to welcome you to this webinar, and which is developed by, it's part of the DICE project. My name is Michelle Wagner, and I'll be moderating today's session together with several of my colleagues who will guide you through the different sections of the manual that we develop as an output of the DICE project. And together we'll be looking at one of the practical challenges that is becoming increasingly important across Europe, which is what happens to digital health devices once they reach their end of life. And I know, like at first glance, you might think like it's very straightforward. It's just waste management topic, right? But after all, the device is no longer needed. We simply recycle or dispose it? And yeah, the answer isn't nearly as simple and clear because as you may all know, a digital health device can simultaneously be a medical device, an electronic device. It can also have a potential source of biological and contamination. It can carry also sensitive patient information, and it also contains valuable raw materials. So managing all of those aspects safely and correctly, requires coordination between many different people. For example, clinical staff, waste managers, logistics, PROs. Producer responsibility organizations, and others that come up on top of my head, right? So before we get started, I just like to briefly cover a few housekeeping points. And to keep the webinar running smoothly, everyone has joined in with the microphones muted, and also the cameras are off, but you can put them on if you wish, right? And we have later on time to open the discussion. We will invite you to speak, as we don't want this webinar to be like a class. We want it to be a little bit more interactive. And if questions come to mind while presenting, please use the Q&A function. I think you can see it. It's on the top of your bar. And you can put you can include your questions, and we will be discussing it, going through your questions at the end of the webinar. And in case, right now we have 90 minutes programmed, in the likely case that we don't go through them, we will respond them and send it to you by email. And we also have planned several points during the webinar to use the Mentimeter to make the webinar a little bit more interactive, as we say, like we want it to be a more interactive webinar. And the webinar is also recorded, so if you miss anything or if your colleagues couldn't attend, they will be able to watch it afterwards. And the presentation slides we will be providing after the webinar. And just a heads up, the manual, the recording, and 5-pagers that we develop, they will be uploaded in the DICE website at the end of the project. And so with that, let's have a look at what we'll be covering during the 90 minutes. And so we've structured, this is the agenda, and we structured today's webinars to follow the same journey that a digital health device follows once it reaches its end of life. And rather than looking at isolated procedures, we look at the complete picture and how each stage connects to each other. And for that, we will begin to introduce you to the DICE project. I know I've been mentioning a lot, so I will provide you, for those of you who don't know the DICE project, I will be providing you like a small explanation, and also like why managing digital health devices is different from managing conventional electronic waste. And understanding the problem is very important, because if we don't fully appreciate like the challenges that these devices have, it's difficult to understand why they need special handling. And yeah, so from there, we'll move into the core of today's webinar, which is like a guided walkthrough of the instructional manual that we develop as an output of the DICE project. And we'll look at the practical steps involved, like from prevention, reuse, sorting, safe handling, transport, treatment, and reprocessing. I might have forgotten one. But our goal isn't just to explain what's written in the manual. So we want to also explain why each recommendation is there and how it can help organizations, healthcare facilities, logistic operators avoid, etc. Yeah, avoid common mistakes and improve safety, and also recover resources and be compliant. And yeah, finally, we'll finish with what I think is the most valuable part of today's session, which is the discussion. And just to mention that the manual was developed with practitioners in mind, but like a focus on operational reality, which is sometimes it differs from country to country and from hospitals to hospital and organizations. So that's why we're particularly interested in, hearing what experiences you have as well. And so by the end of this webinar, I hope you leave not only with a better understanding of the manual, but also like with ideas that you can actually implement in your day-to-day business. And with that in mind, let's start looking at the DICE project itself and why it's this work has become increasingly important. And I know that some of you, as mentioned before, may have been already familiar with the DICE project, while others might be the first introduction. So I will provide you like a small overview of it. So DICE is a Horizon Europe project that brings together 20 partners across Europe, and builds from their expertise, like from different disciplinary. And this diversity is one of the project's greatest strengths, because managing, as mentioned before, managing digital health devices isn't solely like a healthcare issue, or a waste management issue, or a legal issue. Like it across Europe, the use of digital health technologies is increasing rapidly. We saw it like with COVID, right? We see more wearable devices, smart inhalers, glucose monitors, and many other technologies that enter the healthcare system. And these technologies are good for patients. Like I suffer from asthma, so it's really good for patients because obviously they improve the diagnosis, the monitoring, the treatment, and so on. But they also create a big challenge. And eventually, every one of these devices reaches its end of life. And what happens then? What happens then? They find healthcare facilities, some organizations find themselves asking questions that existing guidelines didn't answer very clearly. Like, can this device be reused? Do they contain patient data? Patient data. Is it infectious? Should it be treated as or medical waste, or maybe both? And is there valuable material? Can it be recovered actually? And this is like just on top of my head. And those questions are the type of questions that motivated the DICE project. And one of our objectives has been to translate complex European legislation into very practical guidance that operational staff can actually apply during their day-to-day life, working life. And today's operational manual, well, actually, it's called Instruction Manual for Operational Workers Handling Medical Device, but I'm just going to say operational manual because it's a long name, right? But this is one of the practical outputs, and we're very delighted to share with you. And so I was mentioning that digital health devices are not like other ways. So at first glance, many digital health devices don't look particularly different from everyday electronics, especially small electronics. And just placing a glucose monitor, a fitness tracker, and a smartwatch on the table. And to most people, those, they appear to be just small, ordinary electronic devices with, batteries and maybe some printed circuit boards. But appearances can be very misleading. For example, a glucose monitor that has been used in a healthcare setting may contain blood or other bodily fluids. So it might also contain sensitive patient information. And also it contains batteries that need to be handled safely. And because it's also a regulated medical device, there are additional legal requirements that, simply don't apply to ordinary consumer electronics. So let's briefly take a look at the four main reasons. I just go because I talked already too much. And the first, biological contamination. The four main reasons are: one, the biological contamination, and a device that has been in contact with a patient may pose an infection risk if it's not handled correctly. And that means that the first question shouldn't be how do we recycle it, but the first question should be, can we actually handle it safely? And the second point is patient data. And many digital health devices store personal information, whether directly on the device or through like associated systems. And before any reuse or refurbishment or even recycling takes place, organizations must ensure that the data protection requirements have been fully addressed, and GDPR applies. And the third challenge is the battery safety. We all heard of stories about lithium battery fires in waste facilities, and small medical devices are no exception to this. A damaged or a swollen battery can pose significant risk, and not only during treatment, but also during storage or transport. And it's important to identify this. And finally, we come to the legal framework, the regulatory landscape. And organizations often need to navigate like several different pieces of legislation at the same time, including waste legislation, medical legislation, data protection requirements, occupational safety and health as well. So each framework focuses on a different aspect, but operational staff, they need one practical process that brings everything together. And digital health devices aren't difficult because they are electronics, right? They're difficult because they sit in an intersection of healthcare, technology, environmental protection, patient safety, and recovery of materials. So they're like in a little slotty here. So that's why it makes it so challenging. And now that we see why the digital health devices are different from conventional electronic waste, when developing this manual, we carried out an extensive review of existing guidance, operational procedures, and best practices from across Europe. And we looked at the guidance for healthcare facilities, waste operators, PROs. When I mention PROs, is producer responsibility organizations. I'm sorry, I'm gonna use the abbreviation. And during this review, we found that the challenge isn't the lack of regulations. The real challenge is that these regulations were developed for different purposes, right? By different sectors, and they rarely connect with one another in a way that's very useful when doing like a job on the ground. So, for example, imagine a nurse finishing a busy shift. You removed a digital health device from the patient, and now you need to decide like, where should it go? Can it be reused? Does someone need to remove the patient data first? Is it considered medical we? So for many healthcare workers, those answers aren't immediately obvious, not because they lack training, but because the guidance simply hasn't been brought all together into one practical workflow. So instead of asking people to interpret it like several pieces of legislation, we wanted to provide with this manual one operational pathway that supports, safe and consistent decision making throughout, the process. So now that we have identified the gap, let's look at how the manual has been structured to address it. And this is like an overview of the manual that we have developed. And one of the things that I particularly like about this manual is that it has been designed for the way people actually work. It's not intended to be read cover to cover like a textbook. Instead, it's a practical reference document that people can return to whenever they need guidance. And the structure follows the same journey as the device itself. So that's why I found very interesting. And we start with prevention because the best waste management decision is the one that we never have to make, right? And if we can extend the life of a device through better procurement, maintenance, reuse, we've already achieved a better environmental and economic outcome, right? So from there, we move to collection and sorting because the first decision made when a device is removed is often determines everything that happens afterwards, like a chain reaction. And if a reusable device is accidentally placed into the wrong waste streams, recovering is almost impossible. The manual then follows the device through storage, transport, and then where legislation applies, reprocessing. And another feature I'd like to highlight is the practical tools that we have developed here throughout the manual. And rather than expecting people to remember lengthy procedures, we've included this decision trees, checklists, color coordinated bin labels, and quick reference guides that can actually be used on the floor. And and this is mainly because, for example, if you think about busy hospital ward, and staff doesn't have time to search through like 100-page document every time they remove one device, right? So they need something visual and practical and easy to follow. And that's why exactly we developed these tools to provide like some guidance. And we also develop a 5-pager summary of the manual that will be translated in 5 different languages and provided to practitioners, and it will be uploaded in the DICE website at the end of the project. And just to emphasize that this manual is not intended to complement existing legislation or any standard. It's an internal procedure. It shouldn't replace any legislation or standards or anything. It's just like an internal procedure. And throughout today's webinar, we'll be referring to many of these tools, so you see how they can be used in the everyday practice. And now let's move on into the first stage of circular journey, and arguably the most important one, which is prevention. And I know when people hear the phrase circular economy, recycling is often the first thing that they come to mind, but recycling is actually quite far from the waste hierarchy. I believe that the most sustainable device isn't the one that's recycled successfully, but the one that never becomes waste in the first place. And that's why our manual begins with prevention. This represents a change in mindset, actually. And to understand prevention properly, we first need to look at the waste hierarchy. And the waste hierarchy basically is one of the simplest concepts in circular economy, but also one of the most powerful ones. And it reminds us that not all waste management options are equal. And every time we move down the waste hierarchy, we actually lose more value. And if we prevent waste altogether, we've preserved the greatest value, right? If we reuse a device, we've extended its useful life, extended lifespan, and with relatively to no investment. And Refurbishment, requires more resources, but still retains much of the original value. And recycling allows us to recover materials, but by that stage, we've already lost a little bit of the product. Well, we lost the product itself. And disposal, that we should always consider this one to be the last option. And a useful way to think about this in a practical way is, for example, your smartphone. If your phone only needs a battery, you probably wouldn't throw it away, right? You maybe replace the battery because that's the option that preserves the most value. So exactly the same principle applies to digital health devices. Sometimes relatively small interventions that we can do can actually extend the lifespan. And the challenge is making sure that the organization have procedures that identify these opportunities. And so what to ask suppliers at the procurement stage. One of the biggest opportunities to prevent waste actually happens long before a device reaches the end of life, and it starts during procurement. Most important decisions are made before the product was even purchased. The procurement treatment teams they have enormous influence. So, for example, imagine that two devices that perform exactly the same clinical function, but for example, one has a replaceable battery, may have also spare parts available for 10 years, and a manufacturer that offers refurbishment services. And maybe the other one is sealed, impossible to repair, and only supports like 3 years. So these type of decisions are very important. Even though they may look identical today, their environmental impact over the next decade will be completely different, right? So that's why the question we ask suppliers are so important. We're no longer just buying a product, we're investing in its entire life cycle. Can it be repaired? Will software continue to receive updates? Because some of them, they don't receive updates. Can the battery be replaced safely? Does the manufacturer offer take-back schemes? How is patient data removed? And this type of questions help organizations move away from a buy, use, and dispose mentality towards one that considers the complete life cycle of the device. So we've discussed how procurement decisions can influence the entire life cycle of a device, but even the most sustainable product that can become waste much earlier than necessary isn't handled correctly on a daily basis. And that's why prevention practices are very important. And this is where operational staff plays such an important role. When we think about the circular economy, it's easy to assume that the biggest decisions are made by managers or procurement teams. But in reality, many of the most important decisions happen on the hospital floor or like on the segregation. Like, for example, think about a nurse, right? She's finishing her shift and or like a cleaner collecting devices after a procedure. Every day, these professionals make a really small but impactful decisions that determine whether a device can continue its life or whether it immediately becomes waste. For example, imagine a pulse oximeter. I don't know if you know what it means. Like, it's my daughter thinks like it's a finger puppet. You put it here, and it reads the oxygen saturation levels, I believe, and also some of them they provide the heart rate. So so imagine if the oximeter has a loose battery cover. If that issue is reported early, maybe a simple repair that costs very little can keep that device in service, right? But if nobody reports it, the device is simply thrown away and to the container. So you lost like an entire piece of equipment because just to change the battery, And that's why prevention is not only about procurement, it continues throughout the entire life of the device. Another practice is separating potential reuse candidates as soon as they are removed from service. And I know this might sound not obvious, but once a reusable device is mixed with general WEEE or medical waste, recovering it becomes extremely difficult. So yeah, and the first few minutes after a device is removed from a service are often the most important in determining its future. That's why the manual encourages immediate inspection, careful handling, and routine checking of the devices. And this may seem like small operational steps, but together they can significantly increase the reuse rates and reduce unnecessary waste. So we've successfully prevented unnecessary waste wherever possible, right? So the next question comes on, how do we decide whether a device deserves a second life? And I'm going to try to go a little bit fast on this, but one of the things I like most about this section of the manual is that it simplifies what could be a very complicated decision. And rather than asking dozens of different questions, it's just ask mainly one. What is the highest value option that is still safe and compliant? And if the device is fully functional and safe, then reuse or redeployment should always be considered first, obviously in accordance to legislations and standards and so on. And that might simply involve moving the device from one department to another or transferring to another healthcare facility. If immediate reuse isn't possible, that doesn't necessarily mean that the device has become waste. Perhaps it only needs a new battery, or maybe a cable needs replacing, or maybe it requires recalibration by the manufacturer. So in those situations, refurbishment allows us to restore value that would otherwise be lost. And only when neither reuse nor repair is appropriate should we move towards the waste treatment. And it's important to remember that waste treatment doesn't represent failure. Sometimes it's absolutely the correct and safest option. Our goal is to ensure that every device follows the most appropriate pathway based on safety and functionality and also legal requirements, right? So reuse and redeployment procedures. So this slide shows like the operation of workflows, but rather than reading through each step, I just gonna explain the thinking behind it, if that's okay. And the process is deliberately designed to prevent mistakes before they happen. Everything starts with a visual inspection. Does the device appear intact? Is there any obvious contamination? Is the battery damaged? Has anything happened that immediately suggests that the device shouldn't continue its pathway? Only one of those initial checks have been completed. The device can move into a dedicated reuse container. So one practical point I'd like to emphasize is labeling. And labeling might seem like a minor administrative organization task, but in reality, it's a communication tool. And a clear labeled device that says, for example, reuse candidate, immediately tells everyone who handles the device that it requires to be assessed for reuse instead of just disposing it. And without that label, the device may simply be treated as waste, right? So, and another important point is timing. And the longer the device remains in temporary storage, the greater the risk of physical damage, battery deterioration, contamination, or simply it becomes forgotten. So of course, any device can actually be reused. There are two essential questions that still need to be answered. Is it safe? And does it still contain patient data? Does it also have obey the legal requirements? And and data and functional checks. This is probably one of the most critical stages in the entire reuse process, because it's where the patient safety and data protection comes together. And yeah, a device might look perfectly fine on the outside, but appearances, as we mentioned before, they're not enough. We need to know if the device functions correctly, if the battery, what do we know about the battery, and we need absolute confidence that no patient information remains accessible. Yeah, and you can think about, like, for example, a wearable cardiac monitor. Even after the patient has finished, um, the device may still contain relevant information like clinical measurements, or I don't know, timestamps or so, and it's very relevant. And if that information isn't removed properly before the device leaves the hospital or the clinic, we no longer have just a waste management issue. We potentially have also a data protection incident. And that's why sequence shown in the manual is so important. Safety first, functionality, then secured and erase data. And only once all of those checks have been successfully completed should a device really be approved for refurbishment. And just one final point I'd like to stress is about documentation. Whenever we talk about compliance, evident facts matters. So it's not enough to say that the data was deleted. Yeah, the organization should be, clinic and so on, should be able to demonstrate that the appropriate procedure was followed. And that's why maintaining audit trails and data destruction records is very important. If healthcare professionals have confidence that every reused device has undergone these checks, they are much more likely to support circular practices in the future. And so far we talked about prevention, reuse, and assessment, but eventually every device reaches a point where someone has to decide what happens next, right? So yeah, so we're going to discuss about the collection and sorting at healthcare facilities. And the manual defines 5 sorting streams based on 4 criteria: the intended path, contamination status, the battery physical risks, and data sensitivity. And one of the questions that came up repeatedly during the development of this manual was, can you simply tell me where this device should go? And that might sound like a very straightforward question, but the answer depends on several factors, like, is the device still functional? Is it contaminated? Does it contain patient data? Is the battery damaged? So instead of expecting a poor operational staff to remember dozens and dozens of procedures, the manual simplifies this in 5 practical sorting streams. And you can think of this 5 different pathways a device can follow depending on its condition. For example, imagine 2 identical glucose monitors. One has reached the end of its use, its end of life in a particular ward. It's clean, it's undamaged, but it's still functional, and that device could potentially be reused or redeployed. And the second monitor, glucose monitor, has visible contamination after clinical use and cannot be safely reused without further assessment. So although they look almost identical, they immediately follow different pathways. And that's why visual appearance is never enough. Another point I'd like to emphasize is that these streams are designed to support decision-making and not replace professional judgments. So yeah, so for example, if there's uncertainty about contamination, the safest approach always is to escalate rather than guess. So if you think it's contaminated, it's contaminated. And one incorrect decision at this stage can really affect the patient safety, expose workers unnecessarily, or lead to inappropriate treatments. So the color-coded labels shown in the manual and in this slide aren't simply an organizational tool or administrative thing, like I mentioned before. They really are like a communication tool. And they allow everyone who handles this device afterwards to immediately understand because it's very visual. Yeah, so the next challenge is making sure they're actually implemented consistently within the care code facilities. And one of the things I've learned is that people naturally choose the easiest option available. We normally do it unconsciously, and if procedures are very difficult to follow, they will. It's very hard for people to follow them. So if the correct container is located at the other end of the building, or if the labels are unclear and very difficult to read, it's much more likely that the device will end up in a wrong place, right? So that's why this manual recommends placing collection points at the close as possible to where the device actually is removed safely. And another practical recommendation is the concerned signage. Good signage shouldn't require people to stop and think. The clearer, the better. Yeah. And I also want to highlight the recommendation regarding devices containing patient data. These devices deserve particular attention because they introduce an additional layer of responsibility. And yeah, and ultimately, a well-designed collection point does more than collect waste. So yeah, it supports like a good decision making. And even though good collection system staff still need to recognize when a device presents a higher level risk, um, that's why this slide focuses on two concepts that reinforce the entire manual, which is risk and traceability. So yeah, so let's start with risk, right? It's important to remember that not every device presents the same hazards level. Some devices may have been in contact with patients. Others may have damaged lithium, like the battery's damaged. Some may hold sensitive information. So each of these risks require a different response. And one point I particularly like to emphasize is that operational staff should never feel they need to make these decisions alone. If contamination is uncertain, they should involve like an infection control team or highlight this to the manager. And if data is to be confirmed as erased, they should involve the IT department or the data protection officer in the facility. And if the battery is damaged, then they should isolate it and follow the appropriate safety. So yeah, good operational systems are normally built around teamwork, not individual judgment. And when it comes to traceability, um, yeah, every device should be traceable from collection to its final destination. Um, Sometimes we hear people that word, yeah, they think, oh my God, it's too much paperwork. And most of the time it's true, but traceability is really about confidence. Can we demonstrate that where the device came from, who handled it, what decisions were made? Yeah, so those records become invaluable if questions come later, like, for example, an audit or an investigation or an inspection. So, in other words, traceability isn't just simply about compliance, but it's about accountability and continuous improvement. And I want to now, I know I've been talking a lot right now, so I wanted to give the floor to you guys. And we have prepared a little Mentimeter, so you can take your cell phone and scan the QR code, sorry, and or use this link. And the first question is like, do you currently separate potential reusable devices from waste at the point of removal? Yes or no? Just gonna open the. So if you could go to the Mentimeter and respond. Do
Michelle, maybe you can copy the link to the, because I'm not able to, for some reason, into the chat, in case people are not able to join with the QR code.
Yes, of course.
Sorry, I'm not able to copy.
No, it's okay. Oh. That's why. Okay, I have included the link in the QR code. So yes, so do you currently separate potentially reusable devices from waste at the point of removal? And so far, 50% says yes, and that's a really optimistic answer, and I'm happy to hear that. And 25% no, and the other one says I don't know. And this is very, we when developing this manual, we perform interviews and surveys, as I mentioned before, and when talking to healthcare managers, they, or like someone in the healthcare facility, they some of them they say that they didn't know. So this you are providing like an overview of the results that we actually had. Now we will go to the second question. How does your team currently decide which bin or container uses a digital health device? How do you put it there? Like, is it a written procedure? Do you have training? Do you have informal knowledge passed through staff, or it's just a guess? Like, okay, I'll just put this in here. Maybe I'll give you 1 minute more, so then we can continue. So we can see, wow, 38% is just a guess, and 38% informal knowledge pass between, and that's why we developed these tools, the decision trees and the checklists, so to make it easier for the staff members to see, and also the labels, as I mentioned, it's not just like an administration or organizational thing. It's actually like a communication that it's more visual. I'm a visual person, so yeah. And now we will continue. Now I'll give the floor to Boru Bernat. He's a manager director at EcoSig, and who'll take us through the safe handling, storage, transport, and treatment. And the rest over to you, Borut.
Thank you, Michelle. Hello to everybody. I will present you handling procedures. Handling means all physical and non-invasive activities performed during collection and logistics, such as receiving, moving, sorting, storing, loading, and unloading before treatment begins and without altering the physical structure of the equipment. Handling of a digital health device is special because it poses a risk. The devices could be contaminated with pathogens sufficient to cause disease. If the status of the waste is not clear, it must be treated as infectious. Safety is on the first place. For safe handling, following rules must be respected. The devices, the handling devices must be devices must be handled in designated collection or sorting zones. Then access to unauthorized stuff must be restricted. The devices should not be stacked, crashed, or dropped at any time. The inner bins must be replaced without tilting or shaking the container. When transport the devices, the trolleys or carts must be used. Every damage or leakage or unauthorized access must be immediately reported. When handling digital health devices, personal protective equipment that has been determined in the risk assessment according to the level of the threat must be used. The personal protective equipment are follows. Nitrile gloves must be used when handling all digital health devices. Safety goggles must be used when handling broken devices, visible leaks, or when exists the risk of splatter. When the contamination is expected, apron or gown must be worn. FFP2 and FFP or FFP3 mask must be used when aerosol risk exists, and protective footwear when heavy devices are handled. Operator must feel empowered to stop work and request equipment if it has not been provided. Next slide, please. Special attention must be paid when handling damaged and contaminated devices. Damaged devices may release hazardous substances like gases, coolants, chemicals, or pose electrical hazards. You shouldn't open, break, or dismantle devices yourself. The devices must be handled with caution, especially with cooling circuits, screens, batteries, or internal modules. They must be placed intact, secure transport packaging to prevent further breakage or leakage. They must be delivered to authorized collection center or VE scheme. Batteries can be removed only if can be done safely. Otherwise, the treatment facility should do it. Medical devices shall not be mixed with general VE without flagging the damage. Contaminated devices can pose a risk of infectious waste. They may contain pathogens in quantities sufficient to cause disease. Contaminated devices shall not be cleaned by yourself because they pose a risk to staff. They must be clearly labeled when handling them. personal protective equipment must be used. Contaminated devices must be placed in leak-proof packaging that prevents spills during transport. The sharp components must be separated, and all appliances must be handled per the facility's internal infectious waste protocol, not like general V route. Next slide, please. When handling digital health devices, emergency procedure must be respected. Emergency procedures should be displayed at every collection point along sorting decision tree. In case of lithium battery fire or thermal runaway, you shouldn't use water or foam because it reacts with lithium and intensifies the fire. Then dry powder or lithium-specific extinguisher must be used. If fire cannot be controlled, people must be evacuated immediately, and fire brigade must be called. The doors must be closed in order that close the smoke, and the corridor shouldn't be blocked. The incident must be documented. In case of suspected contamination event, the device must be isolated and placed in a sealed labeled bag. The contaminated personal protective equipment must be removed. The wash hands and exposed skin also. Inspection control officer must be alerted. Also, and the staff who may have been exposed must be notified. In case of sharp injury, the activity must be immediately stopped. The device shall not be put back in the bin. The wound should be allowed to bleed gently. It should be washed with soap and running water for 5 minutes, and don't scrub or squeeze. The wound should be covered with a waterproof dressing, and the incident should be reported immediately to occupational health or emergency department. In case of suspected data breach, don't attempt to investigate or restore the data alone. The data protection officer must be notified immediately, and under GDPR Article 33, National Data Protection Authority must be notified within 72 hours of discovery. Thank you for your attention.
Thank you, Bor, for the comprehensive overview of the safety handling at healthcare centers. Now we give the floor to Sofia Kalini. She is the Senior Project Manager at Green, and will be providing us with an overview of what safe, compliant, or organized storage looks like for these devices. Please go ahead, Sophia.
Yeah, hi everyone. So in the next slides are general recommendations for storage, how to set it up and keep it compliant day to day, and also about smart collection machines and how we use them for interim storage at the locations and during DICE project in real settings. So after items are collected, there is needed dedicated storage area and separate from general waste with a side area for each of the streams, kept dry, ventilated, and protected from sunlight and heat. And of course, it's needed access control. So only authorized staff should be able to get in, and the area needs to be locked outside working hours. Also, as some of devices, they may contain batteries, so it needs a dry powder or Class D extinguisher on site, and damaged batteries must never be stored near the other streams. And since one compromised cell can create a real fire risk. And there also should be scheduled inspections and scheduled emptying. So, for example, every week someone checks the storage area for leaks, damage, and unauthorized access and logs the result. And as well, schedule emptying. Containers get emptied on a schedule agreed with PRO or logistics providers, respecting any volume or duration limit set by national legislation. And usually the healthcare facility waste management lead sets the area up and operators maintain in day to day. So this is general recommendations for foundation for storage. And in the next slide, how it all gets signed and labeled. So the principle here is simple. Every storage area and collection point must be clearly signed and consistently labeled. So container labels need to be color-coded, showing the stream number, stream name, and hazard icon where it's relevant. At the room level, the entrance needs stream identification, hazard warning, if needed, a restricted access notice, and the responsible person name and contact. And if label is damaged, it should be replaced within short period of time, and unlabeled container should never stay in use. And this is also need weekly inspection, so to check if all labels are correct, if everything is recorded, and if there are any gaps. And in the next slide, I will tell about technology, how we can handle or automate some of the steps. So here, one of this is smart collection machines, and this is how it looks in the field, a real deployed unit. So this is smart collection machines CE certified. They're installed mostly across Norway now and also in Europe for collecting different type of circular items. And during DICE, we had a confirmatory pilot, and 25 such machines were installed in 3 countries. Machines are locked by default, and user needs specific QR code to scan to be able to deposit the item. And machines are connected to the cloud. It means that they collect data all the time. And when something is returned, we can collect data and save what was returned, where and when, because of machine learning that is trained to recognize items. Also, we track how many percent bin is full, and we can set up to collect other important data based on requirements. Also depends on the requirements and regulations. We can set up machine to handle one stream only. So covering multiple streams means deploying multiple machines, and local legislations and rules always need to be checked before setting one up. As I mentioned about QR code, the machine is locked by default. The user scans a QR code to deposit an item, which presorts at the point of deposit, so only the machine device category is accepted. Until it's emptied, items are stored safely inside at the location. So the smart collection machine is kind of like interim storage at the location. On the outside of the machine, we can see that this has customized design. We can also place needed instructions and needed labels. and machine generate different type of alerts, depends on the requirement, but in scope of storage at the location, one of the most essential is unauthorized access alerts. So as collected devices may contain different sensitive data or user data, it's very important to track if someone tried to access machine unauthorized. So once someone tried to do something like this, machine generates alert and logs the event if anyone tries to steal the devices or do something to it. So this is the same access control principle from the storage slide, just built into the machine itself. And in our DICE confirmatory pilot for small electronic health devices, the machine itself was the secure storage point with no separate room needed. So machines were were placed at the locations, and devices were inside the machine until the operator empties it on a grid schedule, then move on to the appropriate treatment or use facility. The machine held everything safely, and the operator's scheduled visit was the only point anyone needed physical access to the machine. So storage keeps things physically secure, labeling keeps them identifiable, and together that actually keeps this process safe and compliant. And smart collection machines, they can make this process more smooth and help automate some of steps. Thank you.
Thank you, Sophia, for your presentation. It was quite insightful. Now we give the floor to Lorenzo Gloria. He is the Senior Recycling Coordinator at Recupel and will provide us with an overview of how transport and shipment for digital health devices looks like in the EU.
Hello, my name is Lorenzo Gloria. I'm the recycling coordinator and head of valorization team at the Belgian PRO for e-waste, Recupel. And as a PRO, we organize operational activity from collection to treatment with subcontractors. So I'll be walking you through what's needed to transport the discarded digital health devices. So let's start by looking at what is required before anyone is allowed to collect and transport discarded digital health devices. The important point is that there is no single permit that covers every situation when it comes to transport. So I can unfortunately not give a general administrative manual. There are no general European permits to transport specific waste in specific member states. Only European law that is translated and differently implemented in member states. This is also logical considering the waste transport happens on a relatively local scale very often. Especially in Belgium, it tends to become very complicated considering we have a regional situation when it comes to legislation, but I'll talk a bit about that later. The permits required depend generally on the type of device and on the condition it is in when it leaves the healthcare facility. As already previously stated, so if the device is simply waste electrical and electronic equipment or WEEE, the transport falls under the European WEEE directive, together with the applicable regional waste legislation. The transporter must in that case hold the appropriate registration or permit required by the region where the transport takes place for the Euro code, for the EBC code specific. However, in cases medical devices, they present additional risks. Is a device have been contaminated with blood, fluids, or infectious materials, as already stated before, there's additional legislation governing the health case, governing the healthcare or infectious waste. So these are subject to specific permits, also for infectious waste transport. And then in some certain additional situations, ADR legislation can also be applied, specifically for dangerous goods that contain lithium batteries or other hazardous substances. These transports, they have rules for maximum weight of individual receptacles within a transport that contain devices with batteries. So it is essential that all these required permits are not only obtained, but the contractor obtains them and holds them, but they also have to remain valid throughout the contract period. That is why permits have to be verified periodically before the contract starts, have to be reviewed and checked again whenever a contract is renewed. And they should be ideally included inside the contract specifications. Now, what should happen when it comes to operational collection procedures and the transport? You see at the right side. So this, the right side, the steps are very straightforward. Nevertheless, they are essential to ensure both safety and legal compliance. So one always has to verify that it is the correct container, logically, whether the container is correctly labeled before it is opened. The direct contact with loose devices should always be prevented. There's no need to do that. You're just to collect a bag when it comes to transport. So using the designated bags or handling tools and maintaining the integrity of the containment system throughout the collection process is what's important. So when it comes to collection of bags, these bags are generally in an open state. They must be as efficiently, as quickly as possible, be securely closed and properly labeled with collection date and the collection location. If any bag is ever damaged or leaking, it must be replaced or double bagged immediately. Depending on the types of devices, there may be specific procedures in place. Devices should never be transferred into another container without appropriate containment measures. So it can never keep leaking. So finally, every collection must, of course, be recorded in accordance with the agreed operational procedure. This registration of the pickup creates a first link in a complete chain of traceability. So first the device is collected. Of course, then it is already collected, but it is still in the collection facility locally. Once it leaves there, the entire transport and the movement of the device gets registered. And when it comes to Recupel as a PRO, we register it by the collection point as it gets picked up. The transporter registers the collection of it, and the transporter will also register the deposit of the device or recipient. Next slide, please. So in the waste management, the documentation is very important, as important as the physical transport itself. Everything needs to be duly registered and need to have the sufficient administrative documentation backing it up. So there's a simple rule: a shipment that is not properly documented becomes extremely difficult. It's very hard to try to demonstrate what the transport should go to, the legal compliance of it, the identification of the actual transported goods. It's almost impossible if not properly documented. So every shipment has a waste transfer document or a consignment note, which is a CMR. And this is always registered with the transport. Every transport has a number and a registration. So the document, the CMR, it records key information as who is responsible for the transfer, what is the date and location of the collection, what are the type and quantity of devices. Quantity can also be added later when the transport is received. Also, it's important to include the applicable European Waste Catalog Code, the EBC code, or it can also be locally a URL code, the identity of the transporter, and the destination, the treatment facility that will be receiving the goods, the waste. So once the shipment reaches the destination, the receiving facility also signs the document. This counter signature is crucial because it formally closes the chain of custody and responsibility and confirms that devices have reached their intended destination. From then on, it is the responsibility of the receiver, the treatment facility. Without this confirmation, there's a gap in traceability, making it impossible to prove anything and prove where the equipment ultimately ended up. If the treatment facility say they never received, there was no counter signature, nobody knows where it ever ended up. It's also important to archive these documents for several years. It depends on the legal requirements. We generally do this for 10 years. In practice, these retention periods, they range between 3 and 10 years. The same principle also applies to temporary storage of goods. Of course, every temporary storage is a break between it. No longer becomes one single transport, but it becomes two individual transport for which the same rules apply. So whenever devices enter or leave a storage location, these movements must also be registered, and storage areas, of course, should be secured and clearly identified and managed to prevent loss, contamination, or unauthorized access. It is very simple but crucial to identify your waste properly. I'm sorry to say, in our pilot, we also lost a small part of our collection through bad identification of one of our contractors, which is always just simply a learning experience, but very unfortunate. So the warning at the bottom here summarizes the importance of this process. Moving devices without required documentation is not simply an administrative issue. It can result in legal liabilities for both healthcare institution and the logistics provider. For that reason, no shipment should ever leave a collection point without proper documentation for the transport. Next slide, please. So it's more of a collection than a transport matter in that sense, but every health facility or research lab or institution has people that manage the waste. So these have contracts that should include all the necessary for compliance. We'll do a little Menti here. The question is, of your internal waste managers, do they know the details of all the discarded waste stream? Do they know who is going to pick up? When the rules change, sorting, classification has to be reconsidered. Are they well aware of who collects the digital health device of what type, and what permits do they hold?
Michelle, can you share the link again in the chat, because I don't have access, unfortunately.
Yes, of course. I just shared the link. You can also scan this QR code. We'll just give you 1 more minute to answer. But I can see, Lorenzo, that there are 5 no's and 2 yes. No, 3 yeses.
There's quite a few no's indeed.
Yeah.
So it is very crucial that internal waste managers know, of course, how to organize the waste and sort the waste, categorize it to different fractions, but also who is the logistical operator that collects the digital health devices. It is the logistics company, is it a trader, is it the treatment facility itself, or is it maybe a producer responsibility organization such as Equipel organizing the transport? It's very important to know who does it, and of course also to verify that these organizations have the necessary permits. Generally, when it comes to Belgium, there are registers, national registers, in our case, more regional registers for Flanders, the Walloon region, and Brussels, in which you can check which organizations hold specific permits. So you can also verify yourself before starting a contract with a specific provider, whether he has the correct permits.
I will move to the next question, if it's okay.
Yeah. So the next question is generally, yeah, that's just for one answer, 100%. So in general, things tend to possibly go wrong from time to time. So normally, if the agreements are sound, there's always systems implemented for operational improvements. So things often go wrong according to the responses. Yeah, it happens.
Yeah,
Everybody has experience with this almost, and if they haven't, it's going to happen. So, but we always have to try to be as foolproof as possible. Try to implement everything in the agreements, and whenever there's complaints about non-conformities, whenever something ends up in the wrong place, we always have to register it with appropriate action points and consequences. Whenever a device is improperly sorted or not contaminated, perhaps a container of reed that accidentally goes to incineration, or contaminated equipment that gets mixed, or like you say, a data-bearing device handed over, not properly erased. It's always important to ask ourselves, so where exactly did the process fail? We have a procedure. Where in the procedure did something go wrong? Was it made during identification, during packaging? So the documentation, the transfer, it's important that we are constructive. So we have seen it all as a producer responsibility organization, EQPL, for example, in Brussels, Belgium. But the purpose of these improvement loops, the quality controls, these procedures are, of course, to do it right. But whenever it goes wrong, these controls, the audits, discussions should never be to assign blame, but to be constructive and to try and prevent how these things going wrong in the future, and to make sure there is improvement, to understand where risk exists from the collection chain, because these risks are always there, and to identify practical ways to prevent these situations from occurring. Next slide, please. So for concluding, I'd like to spend a few minutes explaining the legal framework governing the transport of the medical devices. It's often a source of confusion. It's been said already a few times here. There's the discarded medical device can fall under more than one legal regime. This is very important. On one hand, it's electrical and electronic equipment. Once discarded, that part of the device falls under the European WEEE directive, and this is translated for Belgium into regional waste legislation. This is different in the 3 different regions. On the other hand, when a device is infected, contaminated, there's another legislation governing healthcare risk waste that applies. And these 2 legal frameworks exist alongside each other. It's important to realize that it can be very different also regionally. For us, each region has its own waste legislation. It's a regional legislation. So they have different system and different enforcement authority. The healthcare risk waste is also regulated at the regional level. Although the overall principles are similar throughout the entire Belgium, throughout the territory, each region has its own rules regarding classification, packaging, storage, collection, and transport. So in some situations, also specific permits need to be acquired. It needs to be taken into account that things work differently in a different region when one transport discarded digital health devices from one region to another. Also at federal international level, ADR legislation applies for dangerous goods, especially for lithium batteries, as already said before. And federal occupational health and safety legislation protects the workers involved in handling and transporting hazardous materials, which can work out different ways according to the member state and the region. And from an operational perspective, it means that the waste produced, so normally the healthcare institution that produce this waste, must first determine the correct classification of the discarded device. And this is very important because decontamination is key. It's in this day and age, we can no longer simply incinerate contaminated devices. In case they can be decontaminated and seen as simple WEEE, it is essential to bring electronic waste in the WEEE collections chain, because in the WEEE collection chain, it gets properly recycled, whereas in the medical waste chain, things get incinerated. So the same infusion pump, for example, contaminated, must still be managed first according to rules of healthcare risk waste before the electronic components can be recovered. So this classification is critical, and we cannot be lazy and have to be very responsible when it comes to this. I don't know who said it before, I think Norbert, but it is up to everyone's professional opinion to make the right decision here, to exert the precautionary principle, if not to escalate the decision, because it's very important to treat all this collected waste accordingly, for which goes to the next speaker. So thank you very much for your attention.
Thank you, Lorenzo, for the comprehensive presentation. I will now give the floor to Rebecca Bajens. She's a process improvement specialist and account manager at MyRec. And we will be enlightened by the treatment of digital health devices and their pathways. Please go ahead, Rebecca.
Thank you for the introduction, Michelle. So we're now at the point we've done everything to prevent waste. We have collected it, sorted it, and shipped it to a treatment facility. And then we get to the point where we have to decide what can we do. And medical devices in that sense are special because they can potentially be contaminated. And most treatment facilities cannot handle devices that are potentially or are infected. So the first question will always be, is it infected or can it be infected? For example, that could be because it's either actually used infectious or it was accidentally collected in a bin that had medical waste. In that case, it also by touching the other appliances will get infected. If the answer to the question is yes, then you're looking at the medical waste treatment plan. So as Lorenzo also explained, towards incineration. There are some variations. The first is the larger equipment that can potentially be infectious as well, or due to its use. So then we're talking about MRI or similarly sized equipment. Those typically are disinfected, so then they can go to e-waste recycling. Generally, the installer of the new equipment will be able to help with the decommissioning of the old equipment, and they also know what can be done, how it should be decontaminated, how it can get its certificate, so it can be treated. Material or parts can be reused. In case that is not possible, some countries allow for the disinfection, but that's not everywhere in Europe yet a thing. Some countries currently have exceptions because they are doing trial basis for this, but this is something that's better to discuss with your logistics provider if they know if it's possible in your jurisdiction, if they can do the disinfection. So that's the contaminated. If a device is definitely not contaminated, it's generally regarded as e-waste because the RE directive only allows for an exemption to the expectations of the RE directive if it's potentially infected or contaminated. And in that case, it has to go through a lot of the steps Lorenzo just explained, so I won't go over them again. And then it can go to a retreatment facility. And there you have to, as Lorenzo also mentioned, have to make sure that the treatment facility has the required permits, has the required standard, or meets the required standards for the type of medical device that you're sending, because not all treatment facilities can treat all types of e-waste. We have the 6 categories from the redirective. Usually treatment facilities specialize in a handful of them, not all of them. So there you have to be a bit careful. But in general, you will find them with the small household appliances is roughly the category where a lot of the smaller items fall, and otherwise it's the larger household appliances in that same category. The larger equipment can fall. So that's the general treatment pathway for infected and non-infected. And Michelle, if you could continue on. Then, yeah, to the next slide.
There is no.
Yeah, so then we go on to reprocessing, recycling, and like the last overall overview.
Yes, thank you, Rebecca, for the thoughtful presentation. I will now give the floor to Eniko Hayoshi, who will outline what entails reprocessing and recycling and cross-border for the devices.
Thank you, Michelle. Yes, so my name is Eniko Hayoshi and I work for the V Forum, but I will be presenting the reprocessing part, which was developed by the Spanish PRO Ecolec. So I will present now a very short summary of their work. And what you can see on this slide are the steps for reprocessing of digital health devices. So we sort of jump back before treatment a little bit, because of course it's important that if it's possible, then according to the waste hierarchy, you prepare for reuse or reprocess instead of treating it or recycling it. The first most important thing to remember when we talk about reprocessing of single-use devices in Europe is that that it's highly regulated, this topic. And according to the Article 17 of the Medical Device Regulation, it is only allowed in those member states that have specifically authorized this. So the first question is always actually whether you're allowed or permitted to do this at all where you're operating. If the answer is yes, then we can move through a number of steps. So first we need to verify the legal and quality requirements that you see on the slide, like relevant certifications and registrations. Then comes the triage and decontamination phase, where the device is assessed and cleaned to make sure that any biological risks are removed. And this is, of course, according to relevant standards. After which there may be a need to replace certain components. Particularly, we are talking about maybe batteries or other parts that might degrade over time. And once that is done, the device has to go through calibration and safety testing to make sure that it works according to the required standards. So it has to work just like as though it was new and the way it was put on the market. And finally, if everything is successful, of course, the device has to be relabeled and certified, because this will be like a new device. So it has to follow the same labeling and certification requirements that was, as though it was new. And on the other hand, if we find some irregularities in step 3 and 4, so those cannot be successfully implemented, there's something happening to the device, it cannot be prepared for reuse, it cannot be repaired, then we have to send it to recycling. And well, here this was already discussed before, but if this, this is one of the priorities, is the data, the secure data destruction, which may be done by digital way of data wiping, or by physical destruction, with a shredder of the data storage components. And of course, the other important steps include the necessary depollution, material recovery. So circuit boards, for example, should be extracted for precious metal recovery, plastics should be separated, recycled, and batteries need to be handled separately in accordance with the EU battery regulation. We, of course, have to take into consideration transboundary shipments, of course, if these treatment or reprocessing is taking place in another country than ours. And here we have to adhere to the regulations, relevant regulations, depending whether this is considered as waste or product, and whether if it's waste, then whether it's hazardous or not. So this is, of course, regulated by the EU Waste Shipment Regulation, the Basel Convention, and the WE Directive. Thank you very much. This is all. You can see everything in detail in the manual.
Thank you, Annie. That was really comprehensive. And now the part I'm looking forward. Unfortunately, we're not going to be able to do the last Mentimeters, but we want to go through the questions that you have. So I will go through them. Well, if you have any questions, please put them in the Q&A panel. And I know that we just have like a couple of minutes, so I don't see any questions in the Q&A panel. Maybe they're included in the chat. You can include your questions in the chat. There's one from Nikolai. Has your manual been implemented either at full scale or as a pilot at any facility? So as I mentioned in the beginning, we have reviewed many guidelines. We did a desk research of all the manuals that were out there, guidelines, and we also performed surveys and interviews and asked key industry members for input, and but it has not been implemented at full scale. I'm not sure if there's another question. It seems that there's no other questions. Maybe it was clear for all of you. Would any of the presenters would like to, have some last remarks? No? Okay, well then, as we come to the end of today's webinar, I'd like to thank you all for taking the time to join us, and perhaps even more importantly, for participating in the discussion. And if you have additional questions after today's webinars, we'd like to hear from you. And the slides will be shared after the presentation. And as mentioned before, the recording, the manual, the 5-pagers that we developed will be uploaded in the project's website at the end of the project, in September, because we need to edit it. And we hope today's session has provided like a practical ideas that you can take back to your own organization or in the project that you are, or treatment facility and so on, and apply it. And I wish you a wonderful rest of your day, and thank you for being part of today's webinar. And there's the QR code if you want to follow DICE, or also in September will be the end of the event of the DICE project. So if you want to join us, you can scan the QR code and you can have more information there. And thank you for today, and wish you a lovely day. Thank you. Bye, everyone.
Thank you, Michelle.